Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. In this second lecture of week 10 for the course Numerical Analysis, we are going to discuss solution of system of linear equations by LU decomposition method. Decomposition. LU decomposition of a square matrix. It is always possible to factorize a square matrix into a lower triangular matrix and upper triangular matrix, which is called decomposition of a square matrix. To factorize a square matrix is called decomposition, and here today we are going to factorize a square matrix into two matrices. One is the lower triangular matrix and other is the upper triangular matrix. Now the procedure steps for this factorization are: step number 1, first of all, write the system of equations in matrix form Ax is equal to b, and you know already that A is the coefficient matrix, X is the unknown variable matrix, and B is the constant matrix. And second step, factorize matrix A into two matrices, lower triangular matrix and upper triangular matrix. So A is equal to LU, and then using the lower triangular matrix and matrix B, find a column matrix Y, and at the end, using upper triangular matrix and column matrix Y, solve the system for the matrix X, and this X is the variable vectors. In this matrix X, we have the unknown variable of the given system. Now, for example, we have a system of three equations and three unknown: x1 plus x2 minus x3 is equal to 4, x1 minus 2x2 plus 3x3 is equal to minus 6, and 2x1 plus 3x2 plus x3 is equal to 7. So first of all, write this system in matrix form. This is matrix A, which obtain the coefficients of the variable 1, 1, minus 1, 1, minus 2, 3, 2, 3, and 1. And this is the variable matrix, and this is the constant matrix. These constant lies at the right hand side of the system. Now decompose this square matrix A into two matrices, lower triangular matrix and upper triangular matrix, and then putting A is equal to LU, we obtain LUX is equal to B. Now using this matrix U, UX is equal to Y, LY is equal to B, and UX is equal to Y. So in this procedure, first of all, solve for Y using the lower triangular matrix, and you will obtain this lower triangular matrix in the first step. To decompose A into LU, we obtain here in this step lower triangular matrix and upper triangular matrix. So after this step, using the lower triangular matrix and matrix B, find a column matrix Y, and then solve the system UX is equal to Y for X using the upper triangular matrix and the Y matrix for the unknown matrix X. But the question is that how to decompose the matrix A into two matrices, lower triangular matrix and upper triangular matrix. So dear students, in this video lecture I will tell you about the process how to decompose the matrix A into two matrices, lower triangular matrix and upper triangular matrix. In this lecture there are three methods. The first method is Gaussian elimination method. But first of all, note that how to decompose this matrix A. Suppose we have a system of three equations and three unknowns, so we obtain the matrix A. In this matrix A, we have three rows: A11, A12, A13, A21, A22, A23, A31, A32, and A33. This is the matrix A, which is the coefficient matrix. Now to decompose this matrix A into two matrices, lower triangular matrix and upper triangular matrix. So this is the lower triangular matrix and this is the upper triangular matrix. But note that for the LU decomposition implementation of Gaussian elimination, the lower triangular matrix has 1 on the diagonal. In this lower triangular matrix, the diagonal has 1 1. This is formally referred as a Doolittle decomposition factorization. An alternative approach involves a U upper triangular matrix with ones on the diagonal. This is called Crout's decomposition method. So dear students, this point is very important. Note that when we decompose the matrix A into two matrices L and U, then we can put in the lower triangular matrix, we can put in the diagonal of the lower triangular matrix 1 1 1, and these three entries will be unknown. And in the upper triangular matrix we have 6 unknown: 1 2 3 4 5 and 6. And we can write this 1 1 on the diagonal of the upper triangular matrix also. So in this case, now we have 3 unknown in the upper triangular matrix, and there and here we will find 6 unknown, these 3 unknown and these 3 unknown. So you can put 1 1 on the diagonal of the lower triangular matrix, or we can put 1 1 on the diagonal of the upper triangular matrix. So if we put 1 1 on the diagonal of the lower triangular matrix, then the decomposition called Doolittle methods. And if we put these 1 1 on the diagonal of the upper triangular matrix, then the method called Crout's decomposition method. So in this lecture I will tell you about these two methods, Doolittle decompositions and Crout's decomposition method. So this is the procedure of the decomposition of matrix A into L and U matrices. Now if you want to decompose the matrix A into LU decomposition method, you can easily use the Gaussian elimination. First of all, find the upper triangular matrix, and you know that we can obtain the upper triangular matrix simple by echelon form. So convert this matrix, convert the matrix into echelon form, you will get the upper triangular matrix. So dear student, you see here, this is the matrix A. So find the echelon form of this matrix A, you will get the upper triangular matrix. And then when you obtain the upper triangular matrix, you see here, this is the upper triangular matrix. In this upper triangular matrix, these 3 entries will be new entries, and these 3 will be 0, and in the first entries of the first row, like the first row of the matrix A. So when we want to find the upper triangular matrix from the matrix A, here we obtain 3 entries 0, and these 3 entries like is same as the matrix A, and these 3 entries will be a new entries. And after obtaining the upper triangular matrix, we can find easily the lower triangular matrix. And the lower triangular matrix, on the diagonal we have already 1 1, and these 3 entries is 0. And then how to find these 3 unknown? Suppose this is F21, this is f31 and f32. You can find these three unknown easily by dividing a21 divided by a11. This is f21, and divide a31 by a11, we obtain f31, and divide a12 divided by this new entries a dash 22. So we can find these three unknown for the lower triangular matrix, and you can simply multiply these two matrices. We obtain a single matrix, and then by comparing this right hand side to the matrix A, we obtain all these unknowns. 3 unknown in the lower triangular matrix and 6 unknown in the upper triangular matrix. So we have 9 unknowns for these two matrices. So you can multiply these two matrices, and by comparing we can find these 6 unknowns. And the other method is that, first of all, find the upper triangular matrix, convert the matrix A into echelon form. You will obtain the upper triangular matrix. In the upper triangular matrix, you see here these 3 will be 0. These 3, the first row same as matrix A, and these 3 entries will be a new entries. And when we obtain matrix U by Gaussian elimination method, mean by echelon form, then after obtaining matrix U, we can find easily the lower triangular matrix. In the lower triangular matrix, these 3 are already 1 1 1, these 3 is 0 0, and these 3 are unknown, f21, f31 and f32, and we can find these 3 unknown by using this expression. f21 is equal to a21 divided by a11. This is a21 divided by a11. For f31, divide a31, this is a31 divided by a11, and for f32, a12, this is a12 divided by a dash 22, this new entry. So we can factorize the matrix A into L and U. Now in this example, you see here, this is the system of linear equation. So to find the upper triangular matrix, you see here, this is a square matrix A. Now to convert this square matrix A into the echelon form, we can find easily the upper triangular matrix. So to convert this matrix into the echelon form, first of all, adding the first row with the subtract the first row from the second row, we have to make this number 0. So in the echelon form, at this position we need 0, at this position we need 0, and at this position we need 0. So for this position, to make this number 0, subtract the first row from the second row, we obtain 1 1 minus 1, 0 minus 3 4, and 2 3 1. Now to make this number 0, multiplying first row by 2 and then subtract the result from R3, we obtain now the new equivalent matrix 1 1 minus 1, 0 minus 3 4, and 0 1 3. Now multiplying the second row by 1 over 3 and then add the result with third row, this entry will be 0. And now the upper triangular matrix is 1 1 minus 1, 0 minus 3 4, 0 0 13 by 3. Now dear students, know that this is the upper triangular matrix. From this upper triangular matrix, now we can easily find the lower triangular matrix, and you know that in the lower triangular matrix the diagonal entries are already 1 1 1, these 3 are 0, and these 3 are unknown, and we can find these 3 unknown easily by using this expression. Suppose this is a f21, and how to find the f21? a21 divided by a11. You see here in the matrix A, this is a21, second row and first column, this is a21 and this is a11. So divide a21 divided by a11, we obtain 1. This is f21. Now to find f31, To find F31, this is F31, third row and first column. To find F31, A31 divided by A11. This is A31 and this is A11. So 2 divided by 1, we obtain 2. And this is F32. This is unknown. How to find F32? Divide A12 divided by A dash 22. A dash 22 will be in the upper triangular matrix. This is A dash. This is the new element of upper triangular matrix. In upper triangular matrix, dear students, you see in the previous slide that these three will be 0 0, and the first row is matrix A, and these three entries will be new entries which we can obtain by performing the row operations to convert the matrix A in the upper triangular matrix. In these three positions we obtain the new elements. So to find F32, divide A12 from matrix A, A12 first row second column, this is A12, and A dash 22 from the upper triangular matrix, this is A dash 22, this is A dash 23, and this is A dash 33. So A dash 22 and this upper triangular matrix is minus 3. So A12 is 1 and A dash 22 is minus 3. So in the lower triangular matrix, this unknown is minus 1 over 3. Now this is the upper triangular matrix and this is the lower triangular matrix. So here we decompose the matrix A into lower triangular matrix and upper triangular matrix. So in the next step, now find column matrix Y using the lower triangular matrix and the matrix B. Matrix B is given in the given system. This is matrix B, you see here, this is matrix B. Now to find the column matrix Y obtained Y1, Y2, Y3. So using the lower triangular matrix, and we have already find the lower triangular matrix. This is the lower triangular matrix. So using the lower triangular matrix and the matrix B to find the matrix Y by using the forward substitution. This is y1 is equal to 4, and to write this in equation form, y1 plus y2 plus 0 y3, we can write y1 plus y2 is equal to minus 6, and putting the value of y1 here, we obtain the value of y2 is minus 10, and the third equation is 2y1 minus 1 over 3 y2 plus y3. Putting the value of y1 and y2, we obtain the value of y3 is minus 13 by 3. Now using the upper triangular matrix and the Y matrix to find the solution for the given system. This is ux, this is upper triangular matrix, and this is the matrix X, and this is matrix Y, which we have already find in this previous slide. This is the matrix Y, y1, y2 and y3. Now putting here, this is the matrix Y. Now to write this in equation form again, x1 plus x2 minus x3 is equal to 4, and 3x2 plus 4x3 is equal to minus 10, and 13 by 3 x3 is equal to minus 13 by 3. So here we use the back substitution to find the value of x3. To find the value of x3 here, x3 is minus 1, and putting the value of x3 in this equation, we obtain x2 is equal to 4, and now using the value of x3 and x2, using the value of x2 and x3 in this equation, we obtain the value of x1 is equal to 1. This is the first equation, x1 plus 2x2 minus x3 is equal to 4. So using the value of x2 and x3, we obtain the value of x1, and this is the solution of the given system. X1 is equal to 1, x2 is equal to 2, and x3 is equal to minus 1. Now next example. In this example we have x1 plus x2 plus x3 is equal to 5, x1 plus 2x2 plus 2x3 is equal to 6, and x1 plus 2x2 plus 3x1 is equal to 8. Now using the LU decomposition method to find the solution of this system. First of all, write the system in matrix form. This is matrix A, this is matrix X, and this is matrix B. Now to decompose the matrix A into LU, this is matrix A, and this is matrix L, and this is matrix U. And dear students, now I want to tell you about the other methods. We can multiply the lower triangular matrix and upper triangular matrix, and then by comparing the right hand side with the left hand side matrix A, we can find the unknown of the lower triangular matrix. These three are the unknown of the lower triangular matrix, and in the upper triangular matrix there are 6 unknowns. In the lower triangular matrix, on the diagonal we have 1 1 1, and these 3 are unknown. And in the upper triangular matrix we have 6 unknown, 1 2 3 4 5 and 6. So there are total 9 unknowns in these two matrices. So we can multiply these two matrices, we obtain a single matrix, and then by comparing the left hand side to the right hand side we can find easily these 9 unknowns. And in the previous example, you see that we can find first the upper triangular matrix by converting the matrix A into the echelon form, and then we can find easily the lower triangular matrix. But this is the other methods. We can multiply LU matrix, we obtain a single matrix, and then by comparing we can find these unknowns. So after multiplying these two matrices, we obtain DEF, AD, EE plus G, AF plus H, BD, BE plus CG, BF plus CH plus I. So by comparing, D is equal to 1, E is equal to 1, and F is equal to 1. Now AD is equal to 1, EE plus G is equal to 2, AF plus H is equal to 2. And comparing the third row with this third row, AD is equal to 1, BE plus CG is equal to 2, BF plus CH plus I is equal to 3. Now you see here, this is the comparison. By comparison, we obtain D is equal to 1, E is equal to 1, F is equal to 1, AD is equal to 1. Putting the value of D, we obtain A is equal to 1, and AE plus G is equal to 2. Putting the value of A and the value of E, we obtain G is equal to 1, and AF plus H is equal to 2. Putting the value of A and putting the value of F is 1, A is 1, so H is equal to 1. Now comparing the third row, we obtain BD is equal to 1, and we have already the value of D is 1, so B is equal to 1, and BE plus CG is equal to 2. So putting the value of B, putting the value of B, the value of G, and putting the value of E, we obtain C is equal to 1. This is the value of E. Now BF plus CH plus I is equal to 3. Now putting the value of B, the value of B is 1, the value of F is also 1, the value of C is 1, the value of H is also 1. So putting all these values, the value of B, F, C, H, we obtain 1 1, 1 multiplied 1 1, plus 1 multiplied 1 1. So 1 plus 1 2, so 3 minus 2 is equal to 1, so the value of I is 1. So there, now we obtain the 9 unknowns, 3 unknowns in the lower triangular matrix and 6 unknown in the upper triangular matrix. So putting the value of A, B and C, we obtain the lower triangular matrix, and putting the value of D, E, F, G, H, I, we obtain the upper triangular matrix. And now using the lower triangular matrix and the matrix B to find the column matrix Y. This is the lower triangular matrix and this is the matrix B. Now from the forward substitutions, we obtain Y1 is equal to 5, Y1 plus Y2 is equal to 6. Putting the value of Y1, we obtain Y2 is equal to 1. And in the third equation, Y1 plus Y2 plus Y3 is equal to 8. So putting the value of Y1 and Y2, we obtain the value of Y3 is equal to 2. Now using this matrix Y, we obtained y1 5, y2 1, and y3 2. So using the matrix Y and the matrix U, we can find the unknown matrix X. This is the upper triangular matrix, this is the unknown matrix for the system, and this is the matrix Y. Now using the backward substitution, x3 is equal to 2, and putting the value of x3, we obtain, this is equation number 2, x2 plus x3, this is x2 plus x3 is equal to 1. Putting the value of x3, we obtain x2 is equal to minus 1, and x1 plus x2 plus x3 is equal to 5. So putting the value of x3 and the value of x2, we obtain the value of x1 is 4, and this is the solution of the system: x1 4, x2 minus 1, and x3 2. Now another system, 5x2 or 5x1 plus 4x2 plus x3 is equal to 3.4, and 10x1 plus 9x2 plus 4x3 is equal to 8.8, and 10x1 plus 13x2 plus 15x3 is equal to 19.2. So first of all, write the system in matrix form. This is matrix A, this is the coefficients matrix, this is the unknown matrix, and this is the constant matrix. At the right hand side, we obtain 3.4, 8.8, and 19.2. Now to decompose this matrix A into the lower triangular matrix and upper triangular matrix. Now in this example, I want to tell you that we can use the Crout's methods. In the Doolittle methods and Crout's methods, there is a simple one difference. In the Doolittle methods, we put 1 1 1 on the diagonal of the lower triangular matrix, and in the Crout's methods, we put 1 1 1 on the diagonal of the upper triangular matrix. So in this case, in the upper triangular matrix, we have 3 unknown G, H, I, and in the lower triangular matrix, we have 6 unknown A, B, C, D, E, F. So multiplying these two matrices, we obtain a single matrix, and then by comparing this right hand side, the corresponding elements, A is equal to 5, AG is equal to 4, and putting the value of A, we obtain G is equal to 4 by 5, and similarly for the other comparison, we obtain B is equal to 10. Then the first column B, and the first column here, this is 10. So A is equal to 5, B is equal to 10, and D is equal to 10. And using these values, we can find easily other unknowns, like you see here, A is equal to 5, B is equal to 10, and D is equal to 10. So G is equal to 4 by 5, C is equal to 1, E is equal to 5, H is equal to 1 over 5, I is equal to 5, and F is equal to 3. So dear students, you see here AG is equal to 4. AG is equal to 4 mean putting the value of A, you can get easily the value of G. And AH is equal to 1. So putting the value of A is equal to 5, you can find easily the value of H, 1 over 5. And similarly, we can find the value of C, E, I, and F. So using these 9 unknowns, you can easily find the lower triangular matrix. Putting here the value of A, B, C, D, E, F, we can find lower triangular matrix. And putting the value of G, H, I, we can find the upper triangular matrix. Now in the next step, using lower triangular matrix and matrix B, find the column matrix Y. This is the lower triangular matrix, this is the column matrix Y, and this is the matrix B. Now from the forward substitutions, we obtain 5y1 is equal to 3.4. Dividing 3.4 by 5, we obtain y1 is equal to 0.68. And similarly, in the next equation, 10y1 plus y2 is equal to 8.8. Putting the value of y1, and after simplifications, we obtain y2 is equal to 2. And the third equation, 10y1 plus 5y2 plus 3y3 is equal to 19.2. Putting the value of y1 and the value of y2, and after simplifications we obtain y3 is equal to 0.80. so these are the value of y1, y2 and y3. Now using this y matrix and the upper triangular matrix, we obtain the unknown matrix X for the system. This is the upper triangular matrix, this is matrix X, and this is matrix Y. This is the y1 value, y2 and y3. Now using the back substitutions, x3 is equal to 0.80 and x2 plus 2x3 is equal to 2. Putting the value of x3, we obtain x2 is equal to 0.40, and in the first equation x1 plus 5 by 4 x2 plus 1 over 5 x3 is equal to 0.68. Now putting the value of x2 and x3, we obtain x1 is equal to 0.20. So this is the solution of the system. X is equal to x1, x2 and x3. x1 is equal to 0.20, x2 is equal to 0.40 and x3 is equal to 0.80. So dear students, you see here the procedure of LU decomposition method, and this is the end of this segment. Thank you. Allah Hafiz.